Honeywell Aerospace and the Technical Committee Chair for AeroCON 2022. And I'm extremely delighted to chair this plenary session on AI and autonomous systems in aerospace. Autonomous systems are revolutionizing the aviation and aerospace industry, more specifically in autonomous drones and UAS through. And AI and advanced control systems will continue to evolve over the next few years. And they are going to play a very important role in the safety and efficiency of operations of both military and civil aviation. So in this plenary session, we have two eminent speakers, Mr. Sridhar Dharmarajan, Executive Vice President and Managing Director, Hexagon, and Mr. Savyasachi Srinivas, Executive Director, Collins Aerospace. It is my privilege to welcome Mr. Sridhar Dharmarajan. He is responsible for India sales operations of metrology and production software portfolios, as well as MSc software and QDAS. He also oversees the MSc software Indo-Pacific regional business operations across India, Asia, Australia, and New Zealand. He joined MSc Software Corporation in 2007 and established the company's first sales office in the region. He has been responsible for the company's market leaderships and 10x growth. Before MSc Software Corporation, between 2002 and 2006, he was responsible for successfully setting up the Matrix 1 operations in India. He has completed his MS in Mechanical Engineering from Indian Institute of Science, Bangalore. We welcome you, sir, to speak on AI towards autonomy, making aerospace manufacturing smarter. Please welcome.
Good afternoon. Summer energy. Good afternoon. Okay. So thank you, SAE, for giving me the opportunity to talk some of the in one of the interesting topics in the aerospace industry. Normally, people who talk of autonomy, people are always thinking of automotive industry, where you have all these self-driving cars, level 1, level 2, level 3, level 4 autonomy. But if you really see, aerospace has been leading in autonomy for a very, very long time, with some of those programs already there in many of the commercial aircrafts. And today we are talking of many, many interesting innovation and strides the industry has actually taken in the past few years. So I just have a couple of slides on Hexagon. The reason why I have the slides on Hexagon is because Hexagon, I believe, is a well-kept secret in the industry. And this company has got a very different DNA, which has grown about 17 times in the last 10 years, mainly through acquisition. In fact, I was running a simulation company called MSc Software. When I got to know 1 week before that Hexagon is going to acquire MSc Software in 2017, literally speaking, I had to Google who is Hexagon. Because it's a very different DNA grown through in an inorganic way, and growing about 17 times in terms of revenue in the last 10 years. So that's a fast-paced growth, and they're able to retain that acquired companies, the CXOs of the acquired companies are still with us, and it's been a tremendous transformation in this space. So Hexagon is essentially about a $4.5 billion company, about 40 plus billion market cap, 20,000 employees. And in India, we have about close to 2,500 employees in India, which has we've got R&D center in Bangalore and in Hyderabad and Pune, and business offices almost every city. And our industries are mainly mobility or transportation or agriculture, mining, manufacturing, cities, buildings, infrastructure, industrial facilities. So the whole company is divided into two parts. One is the geospatial division and the industrial equipment division. The geospatial talks about the satellites and drones, and we provide the data to people like Google Maps. And then we have the safety and infrastructure. The Novotel brand is part of Hexagon, where you can very precisely tell you the coordinates of any vehicle or any particular system in space. And then also this Leica Geosystems, you must have heard, that's also part of the Hexagon brand. And many of you must be aware of Integraph, which has been a pioneer in India, which is basically for plant design. That's also part of, so the whole concept of Hexagon is to enable an autonomous future. And what we really call autonomy, if you really look at it over a period of time, Industry 1.0, 2.0, mass production, then we had this automation, then we talked about hyperconnectivity in Industry 4.0. Automation is cognitive, autonomous is cognitive automation. The whole idea if automation can happen automatically and based on the data can take intelligent decisions is autonomy. So autonomy is the best use of data that we can actually use, whether it's in automotive or aerospace or any other industry. And that's what Hexagon is trying to do in all these industries that we are there, whether it is agriculture, mining, manufacturing, or smart cities perspective. Just another perspective, just the last slide on Hexagon. About 95% of all the cars that you use, all the transportation, mobility things that you use have Hexagon technology in it. About 90% of all the aircraft, that is defense, commercial, are all having Hexagon technology. Roughly about 75% of all the smartphones has some Hexagon technology, and we're also big into orthopedic implants. So that's just to give you a brief of what Hexagon is so that you can get a right perspective from where are we actually going about, okay? So if you really look at it, the reason why we really call it smart manufacturing, and I strongly believe manufacturing does not just mean producing parts or manufacturing parts on the shop floor. It starts right from the design stage, okay? If you really look at it in any product development time, 80% of the product cost is determined at the 20% of the product life cycle. Because when you're designing, you are actually designing, you are taking decisions on what material you're going to use, you're taking decisions on what kind of manufacturing that you're going to use. Are you going to use a traditional way of manufacturing, or are you going to additive way of manufacturing? You're also deciding how the assemblies are components are going to be assembled together. Whether they're going to be welded, or they're going to be riveted, whether they're going to be, what is going to be the assembly mechanism. So all the decisions are all taken very early. And this is one of the reasons it's very, very critical for us to really understand the manufacturing variables ahead in the design phase. So today we have seen many companies where the design and engineering, the production or the metrology, they're all operating in different silos. And what we are doing is we are actually connecting all these three things together, because ultimately the part that is actually manufactured, the decisions you're taking in the design space, the decisions you're taking in the manufacturing space. So the whole idea is, suppose I'm able to assure a customer that you're as designed, as manufactured, as measured is one and the same, he's going to be really happy about it. Because when you have a digital twin completely of a design process, when you have a digital twin completely of the manufacturing process, finally when you're actually creating the part in a physical way, the designer may say, I designed a great part, the manufacturing guy may say, I manufactured a great part, the metrology guy, the quality guy, and the measurement, because we also manufacture this hardware. So Hexagon is a phygital company, I call it a physical space as well as in a digital space. So we manufacture some of these coordinate measuring machines, which has got a very high accuracy. Some of those machines can measure up to 1/10 of a micron, which is less than a thickness of the human hair strand. So the metrology guy, the quality guy will actually measure the part and say, hey, look at the tolerances on this part. You claim that you have designed a great part. You claim that you have manufactured a great part. So we are actually connecting all these three divisions in a digital thread so that we can actually learn from every process, because the data is getting generated in every space. How do we learn from all these things to ensure that we get it right the first time, and we also reduce the product development time? And as a technology company, as a simulation company, whether you're simulating manufacturing or whether you're simulating design or engineering, our vision is to always eliminate test completely. So our vision is to eliminate tests so that we want to ensure that the zero prototype is made. But that vision always remains the vision, because as you keep eliminating some tests, the products are getting more and more complex, and you need to ensure that at least some of those things may be tested. But in aerospace, we have a totally different kind of a problem that you're solving. We can't really make prototypes of the aircrafts. The first aircraft that you design must actually kind of fly out, okay? So the road towards AI, I know, I don't know whether how many of you were there about 20, 25, 30 years ago when we were talking about AI. AI never really took off at that point of time. And if you really look at the Jeff Moore's curve of the product life cycle, you have the innovators, people buying this technology, then there's a chasm out there. If it is not really kind of adapted by the early majority, you drop in the chasm. then you have the early majority, then we have the late majority, and then we have the laggards which will adopt this technology. So I still remember about in the early 19s, AI had a lot of buzz, but there are a lot of innovative companies that started using some of these, but then it couldn't really kind of go to the early majority where the technology scales in a rapid way, and it dropped in the chasm. Today, AI is becoming a reality because the amount of data that you have generated in the last 30 years. So essentially, we kind of there's data everywhere. We know what happened, we know why it happened, and how it happened, and then this really helps us to really move from a descriptive space to a prescriptive space, and we can even provide a solution. And this is what I call as autonomy, where you may be able to automate many tasks, but at the end of the day, if the task and if those components or if those machines can take decisions based on the data that is generated at various space, then it becomes a prescriptive process automatically. And that's really kind of growth. And today, many industries have really adopted and they have reduced the product development drastically. So the data gets generated over various activity, and the amount of data that has got generated in the last 10-15 years I heard is much more than the data that is actually generated ever since ever since we were created or we were born per se. So there's a cliche where people keep talking that data is the new oil. Data is going to be the guy who actually kind of manages the data, the department which manages is going to be the most valuable asset in the kind of an organization, because today the data is getting generated across the board, but many people are not really kind of using the data, and with AI today, the amount of data that we have, AI is practically possible, which was not really possible maybe 25, 30 years ago. Okay. So sources of data, where all data can be generated, and how do we build the AI models? So you have in the design, you have various kind of data, right? The decisions that you take, the assumptions that you make, the data that is getting generated. You do some structural simulation, you do some thermal simulation, you do some fluid structure interaction. And today's simulations has become so complex, and you are able to actually simulate the reality, the real situation that has happened. About 20-25 years ago, we used to simulate structural analysis, we used to simulate dynamic analysis, we used to simulate thermal analysis separately, and then we kind of designed the part based on the worst case scenario. But today it's not really necessary that way. Today we can simulate what happens in the realistic environment. So we are able to predict if we ensure that our boundary conditions are correct, our load cases are correct, we're able to predict the realistic situation to maybe about 9th decimal point or something of that kind. So there is data, as I said earlier, you're doing multi-physics, different kind of simulation in the design space. Then in the manufacturing space also, you are doing a lot of simulation in the manufacturing space. Today, we can simulate the entire manufacturing process at the component level, and not only that, suppose you are using a Mazak machines or a Fanuc machine or a BFW machine, you can simulate the whole machining happening in the machine itself, so that to ensure that you don't make a mistake and you get it right the first time. And finally, the performance activity, the data that is generated even on the measurement of the quality side, and how the product is actually kind of performing, and there is a data generated. So the assumptions that you have made in the early stage of the design cycle, and finally how the product is actually kind of performing in the real world out there. What is the gap that you really have? Is your product as you intended, as you designed, as manufactured? Is a physical product literally kind of exactly similar to that? And that's the kind of question that you need to ask and ensure that you actually get it there. So the data gets generated at various spaces, whether it is in the design space or the manufacturing space. And today, this is one of the dragonfly families. The nature itself is can give us a lot of ideas, and we can actually kind of generate a lot of data from simulating what is happening in the nature itself. And many of these components can be efficiently designed, because you don't have a better creator than the creator himself. You don't have a better creation than the creator himself who created you and me, right? So the nature is, we can learn a lot, and we have kind of, many of our customers have actually used some of these natural beings out there and see how we can simulate and create a part for us to use in the physical space. Similarly, these are some of the case studies that I'm presenting here. These are all real life case studies. These are not theoretical case studies, and we have some of these customers out there. I would really request you to come to our stall outside where you can really learn from it. And there's a lot of work done in AI simulation on the flight landing space. What happens depending on the angle, what should be the speed, what should be the activity, and this whole simulation can actually be done and predicted accurately in various scenarios, which is actually being used in the commercial environment as well. The other sources of data, not just in the design, manufacturing, it's also on the factory side, where you have a lot of assets. We have processes, the supply chain, the tooling, data flow. All these operations are generating data at various times of your whole the product life cycle or your whole manufacturing life cycle, and you can really see how you can utilize these aspects as well. Okay. So similarly, from an optimized manufacturing perspective, whether it is casting, whether you do additive manufacturing, based on the number of components that you produce, based on the sampling size that you produce, based on the manufacturing process that you produce, you can actually start predicting if this is the process that you're actually using, this is the kind of a part that will actually happen. Okay, so this, and you can go forward and apply your AI engine out there to kind of do that. This is again a very interesting aspect when it comes to services aspect, our own Internet of Things that we actually use as a platform for servicing aspect, what is happening in your operation side. And again, the data is getting generated, huge amount of data at this point, and how do you actually intelligently use this data, process this data to ensure that not only your part, not only your manufacturing cycle, even your services cycle can actually kind of taken care, and you can do many of your services operation in a remote environment today, because based on the symptoms that the customer is telling you, you are able to predict what could be the source or what could be the problem, and effectively go and address it as well. Okay. So the AI solution of the shop floor, as I was really kind of talking about, whether it is inspection data, whether it is the measurement data, whether you do contact or non-contact or light measurements, all these data can actually be used effectively to ensure that, as I said earlier, if some of these knowledge from the physical space can go back to the design space, you can ensure that the designers are actually taking care of all these aspects of it pretty early in the product life cycle. Okay. So this is a composite part from the aerospace industry. So we have our own non-contact scanners to measure what is the density of these fibers, what is the direction of these fibers, because these components' strength depend on the length of the fiber, the direction of the fiber, and the density of the fiber. So it's pretty important for us to ensure that this also helps us in material selection and material design in the early part of the design cycle. What should be my casting process to ensure that I get the fiber orientation the way I really want? And AI can be effectively used in this aspect, and this data is actually fed back from the testing phase or the inspection phase out there. So a lot of interesting work has been done out there. So while we are doing this, we are using a lot of AI for predictive maintenance, let's say in a shop floor. Rather than waiting for the machine to fail, we are able to collect the data from the various machines out there to really understand at what life cycle, at what cycles of operation this machine will potentially fail. So rather than you wait for those machine to fail, you can predict that it's going to fail, let's say in 10 cycles or 15 cycles, and go ahead and replace the part. And we talked about already this inspection. So when you're doing, again, the whole inspection is getting automated, especially you're having this inline inspection to ensure that your quality measurement also is kind of done pretty fast, and there is no bottleneck out there for you to kind of get your product out to the market at a faster pace. You can actually apply some of these AI solution in that area as well. And finally in the performance space, as the product is actually performing, you can capture the data as to, in the realistic world, what is the performance of the machine, and go back and understand the assumptions that you made is actually still valid or not, and go back and correct it in your next phase cycle. This is a very, very interesting example, bird strike example. It's a real life case study that we have done for one of our customers, Because what happens is when your bird strikes, let's say the engine blade, you have a potential issue of engine getting stalled as well. And you can actually, this analysis, so some of this analysis takes days, not hours, it takes kind of days. Because it involves a high level of nonlinearity, and it also involves an explicit behavior, in a very, very short term, what is the kind of impact that is really kind of happening. And just imagining trying to do this. So now for the last 20, 25 years, 30 years, 50 years of aerospace industry, so much of data is getting generated. We can actually, we need not to do those multi-days analysis today. We can actually take the previous data. You must have changed certain components of your aircraft structure. You must have changed certain components of your blades, and you can go ahead and do these, reduce order models to predict how this if the bird strikes in this new material, in this new blades that you design. So you can actually simulate much faster than what you were doing earlier. Okay. So this is, you really save a lot of time in when you're using these data. Finally, I always strongly believe in Kaizen. We always have to continuously improve. There's nothing like we have done our best. And it's a continuous process, whether it is in a design space, manufacturing space, measurement space. It's very important for us to link the virtual data, the digital data, and the physical data to ensure that we are not really talking in 30,000 feet or something like that, and we are making this whole thing, whatever simulation that you're doing, whatever design that you're doing, whatever manufacturing that you're doing, the physical part is actually your as designed, as manufactured part, and this is a continuous learning process, whether it's a design phase, production phase, quality, and finally the services, the MRO activity, and these AI can be used in all these models for us to effectively reduce the product development time and also getting it right the first time and ensuring the quality of these things are getting better as well. Thank you so much. Thank you once again for the opportunity, SAE, for me to deliver this. I'm open to any questions that you may have now or we are at the stall. Please feel free, and we can really show you many of these case studies that we have done and many more than what I actually presented. It's a good idea for us to learn from some of our customers who have already achieved a lot of benefits, and how do you kind of replicate that in our environment as well. Thank you.
I think we might have time for one question. Anyone would like to ask a question? Yes, please. Mike.
Hello, sir. My name is Mudit.
Hi.
Great talk. You talked about as produced and as manufactured. So are you also considering as needed, like the very initial phase of conceptualization, and how do you plan to use AI over there?
Yeah, thank you so much. That's what I said. Before design, also we're discussing as intended.
Right.
Okay, so essentially, yes, we are actually talking about it because at the end of the day, we have so much of knowledge, basically how the physical part is. We have many of our customers where we had a completely different model in the intended phase, and finally in the physical phase, based on various constraints throughout the processes, that particular physical model was looking so different compared to what you are. So you are very right. There is a lot of work going on in that space as well to ensure that, rather than, sometimes what happens is in your intended phase, people may come up with some unrealistic ideas. And we need to ensure that we have this data in our previous experience and come back and say, yeah, we can actually do this, and maybe over a period of time in phase 2 or phase 3 kind of a thing, and to ensure that this whole process is done. So yeah, there is a lot of work going on in that space as well.
Okay, thank you.
Thanks. Thank you so much. Thanks.
Thank you. So on behalf of AeroCON Organizing Committee, we would like to present Mr. Sridhar Rajan a moment of appreciation. So we'll move to the next session. It's my privilege to welcome Mr. Savyasachi Srinivas, Executive Director, Collins Aerospace. He leads the Global Engineering and Technology Center in India for Collins Aerospace in Bangalore and Hyderabad locations. His teams execute both regional and international programs that support internal and external customers globally. He has global work experience in aerospace and defense corporations in the United States and India, with the ability to lead cross-functional and geographically spread teams, where he has led the development of large-scale systems for mission-critical applications in aerospace, aviation, and other engineering domains. He holds a bachelor's degree in mechanical engineering from Bangalore University, a master's degree in industrial engineering from University of Arizona, and a master's degree in technical management from Johns Hopkins University. We welcome you, sir, to speak on AI and autonomous systems in military aircraft programs, current status and opportunities.
Good afternoon, everybody. Ramki, thank you very much for the kind introduction. And first of all, I want to say thank you to the SAE India for putting together this fabulous conference, and special thanks to all the office bearers who I'm sure put in a lot of effort to get us to this phase. This is a very exciting topic, and I'm really happy to be part of delivering this speech and giving you a very high-level overview of what is to come when it comes to AI and military applications, especially airborne military applications. But before I go into that, I would like to spend some time talking about Raytheon Technologies. I don't know how many people know Raytheon Technologies, because it's a company that was formed fairly recently. I would say, when I say recently, last couple of years ago. So maybe spend a few slides talking about the company, and then we will go into the topic. All right, so Raytheon Technologies, if you did not know, is the #1 aerospace and defense company in the world. As of this year, Forbes announced, and that's the list that you see right there, we stand proudly at the top in terms of being the largest aerospace defense company in the world. It was coming together of two large giants that brought together this union, Raytheon Company and United Technologies, which had significant presence in India already. So if you look at it in terms of numbers, and this is pre-pandemic, so some changes may have happened. In 2019, when we came together, the pro forma sales were about 75 billion, and we had about 200,000 strong employees across the globe. So that's Raytheon Technologies for you. We have 4 group companies as part of Raytheon Technologies. Collins Aerospace, that I am part of, and I'll talk to you a little bit more about that. We also have our sister company, Pratt & Whitney, who again, I'm sure is no stranger to a lot of our aerospace and defense professionals here, is one of the leading engine manufacturers, design and manufacturers in the world. Raytheon Intelligence and Space, again, and Raytheon Missiles and Defense, as the name suggests. They work in the military domain, working very closely with our military and intelligence customers, providing world-class cybersecurity, missile defense, and precision sort of missile equipment across the globe. So those are the 4 group companies that form Raytheon Technologies. Coming to Collins Aerospace, $25 billion company. We are about 80,000 employees across the globe, 5,000 of them in India. Like I said, primarily between Hyderabad, Bangalore, and Delhi. Right here in Bangalore, we have both our engineering and manufacturing presence. In Hyderabad, we mainly have our engineering presence, and in Delhi, we have our sales and marketing office. We are headquartered in the United States, and we have presence across the globe. What do? We'll just wait for the picture to come up, and that should give you an idea of what we do. Pretty much everything, right? Except making the plane. We don't make the plane, we do everything. So from nose to tail, anything that you see in blue is us. And the white thing that you see, the engine that is not colored in white, that's because Pratt & Whitney does it. So if you add that, there's nothing on the plane that we do not build. So that's Collins Aerospace for you. So if there is any part of the aircraft that you specialize in and you think of, we have a fairly large presence in it. Specifically to the business units that form the entire blue color in the plane, we have about 6 business units. Start with advanced structures, as the name suggests, nacelles, we've got wheels and brakes, the landing system, cargo, we've got actuation systems. All the heavy mechanical parts are part of our advanced structures business. Avionics is where we bring intelligence into the cockpit, allows pilots to navigate from point A to point B, some world-class avionics equipment on both commercial platforms as well as business and regional jet platforms. Then we have our new entrant, new business unit called Connected Aviation Solutions. You would see the need. Lot of connectivity on board the plane as well as in airports, essentially helping passengers move from source to destination. That's what the team in Connected Aviation Solution does. And then we have interiors, all the creature comforts on the plane. So if you've entered in the plane and all these large carriers make you walk through the first class and the business class before a lot of us get into the economy area, all those seats are built by Collins Aerospace as well. You'd be surprised how complex a first class or a business class seat is. The number of parts are equivalent to some very, very complex aerospace and aerospace applications. A first-class seat costs as much as a Ferrari. So just to kind of give you an idea of how complicated that piece of technology is. And then we have mission systems, again, supports mostly our military customers. We bring a lot of solutions to our warfighters across the globe. And lastly, power and controls, powering our aircraft. So that's what constitutes all the business units of Collins Aerospace. Strong legacy of innovation, and this again, I'm talking mainly of Collins Aerospace. Look at the names out there. These are pioneers, these are stalwarts of aerospace and defense company, starting from Mr. Arthur Collins, if you know Collins Radio, which is where the first words were spoken from the surface of the moon. That was from Collins Radio. Today, about 75% of allied communication happens through Collins Radio, still a very big name in the industry. And then you have people like David Sunstrand, Hamilton, Goodrich, Rohr, Ratier. I mean, these are the people who, shaped the industry as we know today. And they all are part of, and we are very proud that they're all part of the Raytheon Technologies legacy. And it's their vision that we take forward from here on. All right, let's not talk about the topic. When you think about AI, what is the first thing that comes in your mind? I know what comes to my mind, Hollywood. Right? So you think about all these characters, very, very famous characters that you have seen. Hopefully you've all seen some of them. R2-D2 from Star Wars. You have Data from Star Trek. I Am Robot with Will Smith there. Skynet. You remember Skynet, which took over the world in Terminator? That was in AI as well. We were very scared about AI when it came new because we thought Skynet would happen. But for me, one of the most interesting ones and one of my favorite superheroes is right here in the left corner, and that is Tony Stark, Iron Man. The reason being, he had this real super cool assistant called Jarvis. I hope most of you are aware of Jarvis. So he's got this real cool capabilities, which makes an ordinary man like Tony Stark, well, he's not exactly ordinary, he's one of the richest people in the world, but an ordinary guy who doesn't know how to fly and do stuff, Jarvis made him a superhero. That's what the power of artificial intelligence is. So what could Jarvis do? Think about some of the very interesting scenes from Iron Man. Jarvis could create these user interfaces for you that Tony Stark would play around and get sort of play around with the 3D sort of virtual modeling of it. He did that. Jarvis had amazing vision, which means he could make sense out of a lot of visuals, piece together multiple visuals, thousands of images and videos, and bring intelligence out of it. Prediction, Jarvis had a lot of sensors on the suit of Iron Man, so he could predict a lot of things. And also, I would say recollection. Think about all the storage that he had, the memory that he had, and he could make some really futuristic predictions based on all the things that happened in the past. So these are just a few things that Jarvis did, but it was one of the coolest, I would say, implementation of AI, at least that I've known of in the last few years, and really made Tony Stark or Iron Man a superhero. So can a Jarvis-like application come in the future and make superheroes out of us? I'm not sure, but let's see what the future holds. This is what fiction is. Now I'll show you a little bit of reality. And this is reality. Can you play the video, please? So that is reality. Allison is a Collins Aerospace AI platform. This is creating customizable sort of AI solutions for not only our customers, but also people who work in the company every day. AI is going to transform how we do work. This will impact how financial analysts do work, quality engineers do work, software engineers do work, even human resources, manufacturing. Think about the field in any corporate. AI is going to transform how we do things. So when we think about AI, we only think about the end applications. This is also going to completely transform how we go about solving big problems for our customers. Okay, so now I'm specifically going to talk about AI, especially coming to military and military airborne platforms. I can tell you, when it comes to aerospace and defense, we are not the first adopters of technology. A lot of you who are part of the industry know that. In fact, we're probably among the last people who will embrace new technology. The reason being, it's safety critical. We do not bring in technology unless it's really proven, and it'll come into automobiles, it'll come into healthcare, it'll come into all the different domains, and finally aerospace and defense will embrace it. And that's not far from the truth when it comes to AI as well, but we are seen to be going at a much faster pace than any of the previous technologies that we had. So just kind of how things evolved. 2010 is when, and a lot of you speakers talked about, 90s, there being a lot of focus on AI. In fact, my master's thesis in the 90s was actually on neural networks. And after I did it, I didn't know what to use it for. So, I think that thesis is still sitting somewhere at home. But 2010 is when we actually saw some transformation. We saw, with significant improvements in deep learning happen. There was more and more investments happening in the global aerospace and defense R&D sort of department. And then there has been a lot of developments both in terms of computational technology. We have had focus on newer algorithms coming up. And just in 2018, the Department of Defense AI strategy directed the accelerated adoption of AI in military domains. So the government in the US is embracing it. Government across the world is now embracing it because how much transformation has happened. And I can tell you the pandemic had to these different areas, IoT, a lot of speakers spoken about that as well. And that sort of accelerated things as well. What can AI achieve for us? It may not make us superheroes overnight like Jarvis did for Iron Man, but significant reduction in our life cycle costs. It will bring about reduced cycle time in design, simulation, prototyping, manufacturing, and what have you. We anticipate that you will see a significant transformation due to AI in military airborne platforms in the next 5 to 10 years. So this is not a 30-year plan, it's not a 20-year thing. It's going to happen in the next 5 to 10 years sort of horizon, because there is already a lot of research going on in multiple different areas. So I want to maybe show you a few examples of where AI has already been implemented in this space. These are examples from Raytheon Technologies. So the first one is a digital twin that Raytheon Missiles and Defense developed. And this was basically to predict performance of the missile even before launching it, right? So this is a classic example of using AI for performance prediction and using it in simulation and so on. The next one is from Collins Aerospace. This is an ALI mission system that is deployed on drones, which gives you sort of situational awareness as well as threat detection before even sending your high value assets into a highly contested zone. So basically imagine, I don't know if you've seen the Eye in the Sky sort of movie, kind of similar to that. You have drones going and scanning the whole area, figuring out where the threat and the good guys and the bad guys are, and then basically informing your allies to then go enter the battle space, which reduces a significant amount of collateral damage. The last one is again a product that Collins has. It's called the Essentia Platform that we have, and it is used significantly for prognostic health and monitoring. Again, a lot of it being used in the MRO industry for determining repairs and spares and maintenance as well. Okay, some examples from our peers. Boeing and Airbus have done some amazing work in this area. Airbus ATTOL demonstration was a fully automatic vision-based takeoff, landing demonstration in 2022 on a commercial carrier, but obviously this is technology that can be implemented on military platforms as well. The second one you see is a Boeing air power teaming system, which is basically a coordinated sort of maneuver that we had in form of crewless aircrafts that Boeing demonstrated, which is again very cool in applying AI algorithms to teach the aircraft's brain in how to coordinate with other crewless aircraft. And then we have some examples in cybersecurity as well. I'm just going through this quickly so I'm able to take some questions towards the end. So where are we going with these applications? There are lots of applications that are happening right now for AI. These are some of the domains. If you think about it, a lot has been spoken about autonomy. For us as Collins Aerospace, reducing crew operations, going to potentially on commercial airliners, single pilot operation is one of the goals that we are working towards. Obviously using AI technology. Intelligence systems being using airborne battle management, ComNav surveillance on systems on aircraft, cybersecurity. Lot of focus in materials as well. If you look at it in terms of computational materials, advanced manufacturing, we have AI being used in those places quite a bit. Predictive methodologies, I think that's what we have spoken about. A lot of it being used in the MRO industry, both on the civil as well as on the defense side. And lastly, digital transformation. This is how we deliver products to our customers. From design all the way through manufacturing, how we are bringing in digital transformation along with artificial intelligence to make sure we get things right first time. We spent several years in the aerospace and defense industry to bring together a platform. Our ability to find defects even before we start manufacturing or before this is delivered to the customer is going to be a huge leg up for not just the companies but also the customers. So digital transformation is going to be a really, really key area of application for us. Some of the challenges, it's all about data, right? I think a lot of the speakers spoke about, data. That's what it's all about. AI is going to be as good as your data is. So how do you start preparing yourself now to make sure you have a data strategy? I think as companies, we need to start figuring that out. If we have a data strategy in place, implementation of these technologies will become easier as we move forward. Increased computational power is something that is required, but it's also happening at a breakneck speed. But also focus on algorithms that are simple and scalable are also going to be key need of the hour. again, some of the challenges that we see going forward, we talked about computational resources, but certification. We are a very heavy certification sort of dependent industry. We need a lot of the government agencies to certify it. How do you certify something that has got significant AI content on it? That is an area of active research. Robustness of the algorithms, I think that's going to be key as well. Then we have, how do you scale these algorithms? As some of these systems get more and more complex for future needs, I think that is going to be a key challenge that we will need to address. Last but not least, I think cybersecurity is going to be extremely important so that, we don't lose, control over some of these, applications that we are creating. And this is my last slide. How do we take this forward? What should be our approach? And I'm using two words here, safe and fast, right? Safe because of, not this Skynet scenario, but we still need to do it in a way that is done in a way that is, I would say, aerospace and defense appropriate. We focus a lot on safety. So our approach is going to be to do it in a very phase-wise manner. First one is implement autonomy in AI as a capability multiplier. Start in that area and see how we can multiply our capability using some of these technologies. Second one is more of a scalable approach where, we are able to we pick up some of these critical platforms, use simple scalable algorithms to implement these technologies, in addition to our legacy sort of where you will have AI and legacy platforms coexisting together, and clearly provision to override AI/ML. That also has to be a key area that needs to be there. And lastly, when we move forward, I think it will be more multi-aircraft collaborations, system of systems, applying AI to those sort of examples. Clearly, some of the examples that are active research areas are precision targeting, full autonomy, swarm demonstration. The ALE example that I gave you was all about situational awareness and threat detection. So these are all active areas of research. So that's the end of my presentation. Like I said, this is not meant to be a very comprehensive sort of talk on AI/ML, its application in airborne, military airborne systems. But hopefully it gives you an idea of where we are and where we are headed. So with that, thank you very much, and look forward to some questions.
We have time for one question.
Hello, sir. So as we talked about Collins ALE, air launch effect, so I want to know that as we have talked about Jarvis to air, so can Allison be capable of forwarding a blueprint of the image, taking more of the satellite image from a previous location? As you have told in there, the drone will go for the military aircraft and it will give a blueprint type. So can it give a proper blueprint from the images, satellite images, and can conclude it and it can give? So we can basically get how many are standing there and we can get a proper blueprint without actually going there. And a military have a preconceived notion before going there.
No, so a good question. ALE is all about giving you that intelligence even before moving your high value assets into the system. And keep in mind, these are low comm, highly contested areas. So you might not even have satellite intelligence coming in those areas. So this is where these, what I would say, assets go into a battle space, give you that situational awareness in terms of where is the friend, where is the foe, and based on algorithms, based on data, are able to predict, what kind of asset is on the ground. Is it, soldiers? Is it tanks? Is it surface-to-air missiles? Is it, other kind of installations that using vision-based technologies that these ALEs are able to go very accurately pinpoint of what kind of foe actually exists. And it's kind of neat, actually, these drones going like worms, like a swarm, and then basically paint a picture of the entire battle space. And when you see it, you can see it very clearly color-coded in terms of what is green and what is red. And then when you identify the red, you can go and find out in detail as to what exactly constitutes that red at a very high level of accuracy. Imagine that level of intelligence given to war fighters who take so much risk before even going into the battle space. It's just completely transformational. The level of detail that you can get on the ground with this sort of technology is game changing. You know, you can even win the war, you know, just before, you know, even taking off. That's the kind of technology this is bringing to bear. So thank you very much for the question.
Thank you, sir.
Okay. All right, thank you very much. That was the last question.
Thank you for a very interesting talk. So on behalf of the AeroCON Organizing Committee, I would like to invite Mr. Ravishankar Mysore to provide a moment of recognition to Mr. Savasichi Srinivas. Please go to the center.